Welcome to this beginner's guide on C# programming. We'll explore fundamental concepts, classes, objects, constructors, and destructors. These are essential for object-oriented programming in C#, providing a clear, step-by-step explanation for new learners to grasp core principles. A class acts as a blueprint or template, defining the structure, behavior, and attributes for creating objects. It's like an architectural plan, providing all necessary specifications. This ensures consistency across all instances, forming the foundation of object creation. Think of a class like a cookie cutter. The class provides the consistent shape and design. The objects are the individual cookies produced from that cutter, each sharing the same form, but potentially having unique characteristics. This analogy simplifies instantiation. In a real-world analogy, a car class defines properties like color, model, and engine size. It also encapsulates actions such as starting the engine, accelerating, or braking. These properties and actions are common to every car object created from this blueprint. To define a class in C#, use the class keyword, followed by your chosen class name. This signals a new class declaration. The name should be descriptive, clearly reflecting its intended purpose and functionality within your program structure. Class names typically follow Pascal case, where the first letter of each word is capitalized. For example, my new class. Adhering to this C# coding convention is crucial for readability, making class names clear, consistent, and easy to distinguish. Classes contain members, fields for storing data, or methods for performing actions. Fields are variables holding data specific to an object, like a person's name. Methods are functions defining actions an object can perform, often manipulating its internal data, encapsulating behavior. Fields are variables that hold data related to the class, such as an int age or a string name. Methods are functions that operate on this data, encapsulating behavior. They define how an object interacts with its own data, allowing for dynamic operations. Access modifiers like public and private control the visibility and accessibility of class members. A public member is accessible from anywhere, while a private member is restricted to access only within the class itself. This promotes encapsulation and data protection. An object is a concrete instance of a class, a real realization of its blueprint. If a class is the plan, an object is the actual building. It's an existing entity in memory, brought to life from the class definition, embodying all properties and behaviors. Each object is unique. You create an object using the new keyword. This process, called instantiation, allocates necessary memory space for the new object on the heap. It then calls the class's constructor to initialize that memory, preparing the object for immediate use. This is how a class becomes a functional entity. Once created, you can access the object's fields and methods using the dot operator. This operator acts as a bridge, allowing you to interact with its internal components. You can retrieve data from fields or invoke methods to perform actions, utilizing the object's defined members effectively. You can create multiple objects from the same class, each with its own unique data. From a single class blueprint, numerous distinct objects can be instantiated. Each is an independent instance, possessing its own data in its fields, even while sharing the same structure and behavior defined by their common class. Here's an example of a simple person class and how to create and use its objects. On screen, you'll see the person class with name and age fields, and an introduce method. We'll demonstrate creating an object, assigning values, and invoking methods, showcasing the full object lifecycle. Constructors are special methods used to initialize objects immediately after they are created. Their primary function is to ensure every new object starts its life in a well-defined and usable state. This prevents potential errors from uninitialized data, making objects ready for immediate use. The primary purpose of constructors is to ensure new objects are in a valid and ready-to-use state. By executing initialization logic, such as assigning default values or performing setup, constructors guarantee an object's integrity from instantiation. This is vital for correct program functioning. If you don't define a constructor, C# automatically provides a default constructor. This public, parameterless constructor is generated by the compiler. It ensures that objects can always be instantiated, even without explicit initialization logic, providing a basic creation mechanism for every class. This default constructor has no parameters. It initializes fields to their default values, 0 for numbers, false for booleans, and null for reference types. This provides a baseline state for all newly created objects, ensuring they are not left with arbitrary memory values upon creation. A parameterized constructor allows you to initialize objects with specific values when they are created. These constructors accept one or more parameters, enabling you to pass specific values at instantiation. This initializes an object's fields with meaningful data right from the start, tailoring each instance to its specific requirements. You pass arguments to this constructor when instantiating the object. The values for initialization are provided directly within the new keywords call. These arguments correspond to the parameters defined in the constructor's signature. For example, new person ensures immediate and precise setup. A class can have multiple constructors with different parameter lists, a concept known as constructor overloading. Each constructor must have a unique signature, differing in the number, type, or order of parameters. This flexibility allows various ways to instantiate and initialize objects, catering to different creation scenarios. You can also call one constructor from another using this keyword. This avoids code duplication and promotes cleaner design. It's useful when multiple constructors share common initialization logic, allowing you to centralize that logic in one constructor and call it from others. Here's the person class with both a default and a parameterized constructor. On screen, you'll see it enhanced with a default constructor for basic initialization and a parameterized one for specific name and age assignment. This demonstrates how a class can offer multiple pathways for object instantiation. Destructors are special methods used to perform cleanup operations when an object is no longer needed. These operations execute just before an object is permanently removed from memory. They ensure any resources it held are properly released, preventing resource leaks and maintaining system stability. Destructors are primarily used to release unmanaged resources. These are resources not directly controlled by the .NET runtime, such as operating system file handles, network sockets, or database connections. Destructors provide a last resort mechanism to ensure these external resources are properly closed or freed. In C#, the .NET garbage collector automatically manages memory for managed resources. The GC efficiently reclaims memory from unreferenced objects. This robust automatic memory management makes explicit destructors rare in typical C# development, as they are generally not needed for managed memory cleanup. The syntax for a destructor uses a tilde followed by the class name. This unique prefix clearly identifies it as a destructor, differentiating it from constructors or regular methods. It signals its special cleanup role, which is managed by the runtime, not directly invoked. Destructors cannot have access modifiers or parameters. Unlike constructors or regular methods, they cannot be adorned with public or private, nor accept any arguments. Furthermore, a class is strictly limited to having only one destructor. These rules simplify their implementation. The garbage collector determines when to call the destructor. You cannot call it explicitly. Its execution is entirely managed by the .NET GC, which non-deterministically decides when to run it during cleanup cycles. This makes their timing unpredictable and unsuitable for immediate resource release. For more controlled resource release, especially with unmanaged resources, the iDisposable interface and its dispose method are preferred. Implementing iDisposable allows developers to explicitly and deterministically release resources when no longer needed, offering greater control and predictability than destructors. Always follow C# naming conventions for classes, fields, methods, and constructors to ensure code readability. Use Pascal case for classes and methods, and Camel case for local variables. Consistent naming enhances code readability, making it easier for you and others to understand and collaborate effectively. Writing clear and well-documented code is crucial for maintainability and collaboration. Well-structured and commented code is easier to understand, debug, and extend. This practice benefits your long-term projects and is vital for team environments, fostering effective collaboration and reducing development friction. For proper resource management, especially with iDisposable objects, always use using statements. This indispensable tool ensures the dispose method is automatically called when the object goes out of scope, even if an exception occurs. It guarantees timely and reliable resource cleanup, preventing resource leaks. Remember, destructors should only be used when dealing with unmanaged resources that the garbage collector cannot handle automatically. They are a specialized tool for external resources. For all other managed resources, the GC handles cleanup, and for explicit managed resource release, iDisposable is the recommended approach. In summary, classes are blueprints, defining structure and behavior. Objects are their concrete instances. Constructors initialize these objects into a valid state upon creation. Destructors, though rarely used, handle the cleanup of unmanaged resources, completing the object lifecycle. These concepts form the foundation of C# OOP. We encourage you to practice these concepts by writing your own C# code and experimenting with different scenarios. Solidify your understanding by actively coding, designing classes, and implementing constructors. Hands-on experience is invaluable for truly grasping these foundational principles and building confidence. For further learning, explore online tutorials, official documentation, and coding exercises. Deepen your knowledge by consulting authoritative sources and challenging yourself with practice problems. Continuous learning and hands-on practice are key to becoming a proficient C# developer and mastering these concepts. Thank you for watching this beginner's guide to C# classes, objects, constructors, and destructors. We hope this detailed exploration has provided a solid foundation. Keep coding, keep learning, and we look forward to seeing what you build as you continue your journey in C# development.